Hello everyone, welcome to the tutorial on NPN and PNP transistor operation. So when we look at NPN and PNP transistor operation, we basically mean that the transistor is biased. That is, we are applying an external biasing voltage. So two biasing voltages will be applied. So let us look at NPN transistor first. So let me draw the configuration of the NPN transistor, and we have seen previously in the unbiased case that our outer layers, that is the emitter and the collector, was heavily doped while the base was lightly doped, and there were a layer of ions created on either side of the junctions. So when I draw the configuration here, I will be applying forward biasing to the base emitter junction and reverse biasing to the collector base junction. So the ions that were initially set up on either side of the junctions, you can see how the width variation is there. So you can see that the ions that were set up in the NP junction have become narrow, while the PN junction ions have become wide. The layer of ions have become wide. So for correct operation, as I told, the base emitter junction should be forward biased and the collector base junction should be reverse bias. So what I mean by that is that when I say forward biasing means I will be applying positive to the P and negative to the N. Reverse biasing means I will apply negative to the P and positive to the N. So let me draw the barrier potentials that are set up now. So since I am forward biasing, the width of the depletion region becomes narrow and the width of the depletion region at the PN junction becomes wide because it has been reverse biased. And that is what we have understood when we looked at the PN junction diode, right? So when you are forward biasing, the width of the depletion region becomes narrow while the width of the depletion region becomes wide when it is reverse bias. And as we told, since the base is lightly doped and emitter collectors are heavily doped, and since these layers, that is N is having majority electrons, P is having majority holes, what we observe is that because of the reduce in the barrier potential in the NP junction, the electrons are emitted into the base, and hence the name you have emitter. And the holes which were present will flow from P type to N type emitter. But because the base is lightly doped, the collector, which is heavily doped, will allow all the current to flow from base emitter junction, which consists of the electrons entering into the base from the emitter. So the electrons are the majority carriers in the NPN device. Also, some of the charge carriers which are entering the base from the emitter will flow out via the base terminal. Because the base region being very lightly doped, only few holes in the base will recombine with the electrons from the emitter. So from the minority point of view and the majority point of view, what we can say is that reverse bias junction opposes the flow of majority carriers while assisting the flow of minority carriers, and minority carriers are holes from the n side and electrons from the p side. So, if you look at the forward biasing, it is equivalent to saying we are using a PN junction diode, right? So, we can make use of a silicon diode of 0.7 volt, or if we are using a germanium diode, we can say that it is having a barrier potential of 0.3. So, when the VB voltage decreases, that means the forward biasing is decreased and reduced amount of current will flow from emitter through the base to the collector. So, if the VB voltage is equal to 0, that means the current flow is negligible. Whereas if you increase the VB voltage, that means there will be higher flow of current. So, this VB variation will control the flow of current from emitter to collector. Now, if you see the PNP transistor, in PNP transistor we have the base emitter junction, which is forward bias, and the collector base junction, which is reverse bias. So, let me draw the configuration of the PNP transistor. So, in a similar manner, initially in the unbiased case, we have the layer of ions set on either side of the junctions. So, because we are forward biasing the base emitter junction, that is why you can see the width of the depletion region is very narrow, while since we are reverse biasing the base collector junction, the width is higher. Holes are the majority carriers in the p side and electrons are the majority carriers in the n, and we have the layer of ions that are set up, negative ions on the p side and positive ions on the n side. So, we can see the base emitter junction and base collector junction. So, here holes are emitted from the p type emitter across the forward bias base emitter junction into the base. So, in the lightly doped n type base, the holes will find few electrons to absorb and some of the holes will flow out via the base terminal, but most of them are drawn across the collector by the positive and the negative electric field at the reverse bias collector base junction. In this case also, the variations of the forward bias voltage VB will control the small base current and much larger collector and emitter currents. So, in the PNP transistor, the majority carriers are holes and the current flow will be mainly due to the majority charge carriers.